Okay, so today we're going to finish off our discussion of 4.6, and we're going to look at absolute value inequalities. So when we're dealing with absolute value inequalities, in a way they are directly related to our equations that we saw previously in chapter 2. And even earlier in this chapter we've mentioned them as well. So as we're looking at our absolute value inequalities, we're going to have some sort of expression in an absolute value sign. And then we're going to have some sort of inequality symbol next to it. So either less than or equal to, a greater than, or a greater than or equal to. We're going to start by focusing on our less than problems. Right? So if we have an expression that is less than or equal to, right, some sort of number on the other side, we want to pay careful attention to what that number is on the other side. If that number is positive, which we're going to see in most of our cases, right, then we're going to rewrite this as two equivalent expressions. Our expression is less than whatever value we have. Then we're going to use the word and then we're going to have our expression is greater than the opposite of that value. So we're going to rewrite this as two different statements, solve those, and use that to get our final answer. If this number over here is negative, right, then we're going to say that there is no solution, right? The empty set is our solution because it's impossible for our absolute value to be negative. If we have our absolute value is less than 0, then we get no solution. If it's less than or equal to 0, we actually get just one solution where our expression is going to be equal to that 0. We'll talk a little bit more about our negatives and zeros on the last page of this section, but for the most part we're just going to focus on and concentrate our efforts on what happens if this is positive. So for this particular example down here, x is less than 5. Right, so x is in our absolute value. So we're going to start by writing that x is less than 5. We just copy the statement down exactly as it looks, and we're going to drop our inequality symbol. Excuse me, our absolute value symbol. And then we're going to put the word and in here. Right? So x is less than 5, and x is inside our absolute value, so we start with that. Then we're going to flip our symbol to a greater than, and then we're going to flip our sign. So x is less than 5, and x is greater than negative 5. Thinking about what we did in the previous examples, x is less than 5. Means that we have an area shaded to the left of 5. Right? X is greater than negative 5. Means we start at negative 5 and we go towards the positive direction. Right? And if we look at the word and is where they overlap. So we just want this negative 5 to positive 5. So we shade our final answer in on our number line, and we write our answer in interval notation. All right, so down at the bottom of the page, we have our other type of inequality symbol, a greater than symbol. Right? So as we're going through and we're solving these, the first thing we want to do is we want to look at what type of inequality symbol do we have. Do we have a less than or equal to, or do we have a greater than or equal to? The difference is, right, instead of thinking about an and problem, we're thinking about an or problem. So if we have a positive number, we start kind of the same way. We drop our inequality symbols. But then instead of writing the word and, we're going to put the word or in there. And then for our other statement, we're going to do the same thing that we did in the last one. We're going to flip our inequality symbol and change our sign. Right? Underneath there, a couple of other things to mention. If our number is negative, then that should be an R. All real numbers is a possible solution. If we are greater than 0, then we can rewrite as our expression does not equal 0 and go for there. And if we're greater than or equal to 0, then all real numbers is also a possible solution. Again, we'll talk a little bit more about those in the last example that we're going to go through, but we're going to focus on this first case. What happens if this is positive? All right. So this time we have the absolute value of x is greater than 5. So I'm going to write this again. We're just going to drop our inequality symbols. X is greater than 5. And then we're going to say or X. Now we're going to flip our symbol to a less than and flip our sign to a negative. So X is greater than 5. Right? Means we would start there and go to the right. X is less than negative 5. Right? Means we would start here and go to the left. Okay. So our final answer on our number line is going to be both portions shaded in. And then in interval notation, we're going to say negative infinity to negative 5 union positive 5 to positive infinity. Right, so these two ideas here, right, these are going to be key to the next few examples that we're going to go through. Okay. So on the next page, our first example here, we are going to look at, and we are going to start with less than absolute value problems. Right, so less than, right, means we want to think about the word and. Right? So when we're writing out our answers, right, we're going to use kind of this to model what we're going to do. We're going to have two different pieces of our number line, and then our final answer is going to be the and area that is shaded in between. All right. So let's look at this first example here. Again, we're told to solve a graph, write our answer in interval notation. So this time we don't just have a x in the absolute value, we have an x plus 2. So I'm going to rewrite this as x plus 2 is less than 6 and x plus 2. Right, so that part doesn't change. We flip our symbol, so instead of a less than sign, we're going to have a greater than sign, and we flip our sign. So instead of a positive 6, we're going to have a negative 6. Right. Then I'm going to go ahead and solve this one. So I'm going to subtract 2 from both sides. I get x is less than 4. Right, so thinking about my number line, I have x is less than 4. Right, now I'm going to solve my other equation. Same thing, nice one step, subtract 2 from both sides. X is greater than negative 8. So we start at negative 8 and we go to the right. And means where they overlap. Right? So they overlap from this negative 8 to this positive 4. So our interval is from negative 8 to positive 4. Let's go ahead and do another one. So same thing we're going to do. We rewrite our equation. Excuse me, our inequalities. 2x plus 3 is less than 11. And the 2x plus 3 part that was in the absolute value doesn't change. But then we're going to flip our symbol to a greater than, and we're going to flip our sign to a negative. So we're going to subtract 3 from both sides. Oops. 2x is less than 8. Divide by 2. X is less than 4. So on our number line, right, x is less than 4 is there. Subtract 3 from both sides. 2x is greater than negative 14. Divide by 2. X is greater than negative 7. So we start at negative 7 and we go to the right. Right? And means where they overlap. Right? They overlap from negative 7 to positive 4. Okay. Right? So less than or less than or equal to, right, means an and. Right. Now this last one on this page, notice that the only difference is instead of just starting with our absolute value by itself on one side, we have an extra number. Just like we did back in chapter 2 when we were solving absolute value equations, the first thing we want to do is make sure that our absolute value is isolated. So we're going to subtract 2 from both sides, leaving our absolute value symbol here. So we have the absolute value of 2x plus 5 is less than 7. Right? Now that we have isolated our absolute value on the left, we're going to rewrite our equations or inequalities. 2x plus 5 is less than or equal to 7, and 2x plus 5, flip our symbol. So instead of a less than or equal to symbol, we're going to have a greater than or equal to. And instead of a positive 7, we flip our sign to a negative 7. Right. Subtract 5 from both sides. 2x is less than or equal to 2. Divide both sides by 2. X is less than or equal to 1. All right. And then in our other equation, inequality, subtract 5 from both sides. 2x is greater than or equal to negative 12. Divide both sides by 2. X is greater than or equal to negative 6. Notice that I am using our square brackets for our notation this time because we have the equal to part underneath our symbol. Okay. So and is the area where they overlap. They overlap between negative 6 and 1. And so our final answer in our interval notation, negative 6 to 1, again, surrounded by square brackets on both sides. All right, so every single one of the problems on this page, we are looking at a less than problem, right? Less than always means the word and. All right, now going back to the previous page, previous example, remember that if we saw a greater than means we're going to use the word or instead. So we're going to go through a few problems that are going to have greater than or equal to problems, and we're going to use the word or when we rewrite our problems here. All right. Okay, so less than means and, greater than, right, is going to mean or. So first thing we're going to do is rewrite our inequality. X minus 2 is greater than 5, or x minus 2, flip our symbol, greater than to a less than, flip our sign to a negative. Right. Add 2 to both sides. X is greater than 7. Right. X is greater than 7. Starts at 7 and goes to the right. Add 2 to both sides. X is less than negative 3. Starts at negative 3 and goes to the left. Right. This time we're thinking or, so we want both pieces of our interval. Or means union, so we're going to use our union symbol in our interval notation. Negative infinity to negative 3, union 7 to positive infinity. Okay. All right, let's do another one. 3x minus 5 is greater than or equal to 2. Right, we just drop our symbols. Or, because it's a greater than, 3x minus 5 doesn't change, but we flip our symbol to a less than or equal to, flip our sign to a negative. Right, add 5 to both sides. 3x is greater than or equal to 7. Divide both sides by 3. X is greater than or equal to 7/3, or if we change it to a decimal, 2.3 repeating. Add 5 to both sides. 3x is less than or equal to 3. Divide by 3, x is less than or equal to 1. The only reason I'm changing my fractions to my decimals and I'm writing them out is just that way we have the appropriate place to put these on our number line. All right, so 2.3 is a little bit past 2. It's a less than or equal to, so we're going to use a square bracket. All right, x is less than 1. It means we're starting at 1 and we're going to the left. All right, our final answer we want to shade in on our number line. And then we're going to write our final answer in interval notation as well. So negative infinity to 1. 1 gets a square bracket, infinity always gets parentheses. Union 7/3 to positive infinity. Again, fractions or decimals doesn't really make a difference. Decimals give you a good approximation of where to put them on a number line. As you're going through the homework, just make sure you're paying attention to the instructions that you are being given in the assignment. All right, looking at C, notice that we have the same problem that we did in the last example on the previous page. Right, we're going to start by isolating our absolute value. So the first thing we're going to do is subtract 1 from both sides. Right? So then we have the new absolute value inequality that 2x minus 3 is greater than or equal to 4. Right? We have to do this step first. We have to get our absolute value isolated first. And we're going to write this as 2x minus 3 is greater than or equal to 4, or 2x minus 3 is less than or equal to negative 4. All right, add 3 to both sides. 2x is greater than or equal to 7. We divide both sides by 2. X is greater than or equal to 7 over 2, which is the same as 3.5. Add 3 to both sides. 2x is less than or equal to negative 1. Divide both sides by 2. X is less than or equal to negative 1/2, or negative 0.5. All right. Here we have less than or equal to, greater than or equal to, so we're going to use square brackets again. All right. So we go from 3.5 towards positive infinity, and we go from negative 1/2 towards negative infinity. We get the same thing for our final answer on our number line. And then our final answer in interval notation, right, negative infinity to negative 1/2 union 7/2 to positive infinity. All right. Last but not least, we're going to look at a couple of examples when we're dealing with negative numbers and zeros. So we talked a lot about absolute value previously in the semester. And as far as the negative numbers go, it doesn't matter if we have a less than or equal to, or less than or greater than or equal to greater than. We want to decide, is this something that's always true? Is this something that's impossible? Or is this something that is only true sometimes? All right, so let's look at A to start with. 5x plus 1 absolute value is less than negative 4. This part here, this less than negative 4, right, that is impossible. Right? It is impossible for our absolute value to be less than a negative number or equal to a negative number. So if something's impossible, we don't have to work through the entire problem. We can jump right to the empty set. This first statement in B, where we're saying less than 0, well, that's the same thing. That is also impossible. So this one here also has a solution of the empty set. Right? So it's impossible to be less than or equal to a negative number, or less than 0. Right, now if we compare that to something that's not impossible, but something that's always true, that would be a case as in this one here. Right? The absolute value of 5x plus 1 is greater than or equal to negative 4. It doesn't matter what we plug in there for x, right? Because whatever we plug in there, we're going to get a positive number. And positive numbers are always going to be greater than negative numbers. So this is a case where it's not impossible. It is always true, right? If something is always true, writing our answer in interval notation, we could write negative infinity to positive infinity, right? Or we could say all real numbers. Now if we look all the way down at the bottom of this page, this greater than or equal to 0, this is another case that is always true. So this last one is another case where our answer is going to be negative infinity to positive infinity in interval notation, or all real numbers. Now, notice that I skipped a couple in here. Right? The couple ones that I skipped, right, we're going to have to kind of think about. So we're going to look at this one here. We can work through this one a couple of different ways. We could say that it is not equal to 0, or we could work through it like we did our greater than problems on the previous page. So I'm going to go ahead and do it that way. So using this case, 2x minus 2 is greater than 0. Right? That means that 2x minus 2 is greater than 0, or 2x minus 2, if we flip our symbol, we get a less than. And there is no such thing as a negative 0, so I'm just going to put a 0 there. What's going to happen if we solve this? Right? We are going to get x is greater than 1 or x is less than 1. Right? If we add 2 to both sides and then divide, we get an answer of 1 for each. But x is greater than or x is less than. Right? If x is greater than 1, that means we're going to have a parenthesis going in that direction. If x is less than 1, that means we're going to have a parenthesis going in that direction. Right? Both sides are going to be shaded in, but we cannot use the value of 1. Right? So we don't have all real numbers. We have everything except, right, x cannot equal 1. So if we write this as an interval notation, we're going to write negative infinity to 1 using parentheses, union 1 to positive infinity. Right, now C is kind of similar. Again, we're not going to have either the empty set or all real numbers. We're going to have something else. Right, so I'm going to do the same thing here. I'm going to rewrite this. I'm going to say that 3x plus 9 is less than or equal to 0, and 3x plus 9 is greater than or equal to 0. Right? If we solve this, we get that x is less than or equal to negative 3, and x is greater than or equal to negative 3. Right? Well, it's impossible for our solution to go in both ways. We can't both be less than and greater than at the same time. So the only place that these overlap is at our single individual value of x equals 3. So our only solution for this problem is going to be that x equals 3. So there's only a couple of these in your homework. So as you're going through your homework, just kind of use this page as your guide. You want to think a little bit about why these are either always true or impossible, or the ones that we actually get solutions to. But you want to kind of focus your energy and effort in your absolute value problems to the less than or greater than, like the ones that are on the previous page, that have a positive number that you actually do some solving to get to your number line and your interval notation.